Hello there, my name is Gregory Carlson. Welcome to College Algebra, one of the harder sections, 3.3. So you remember I drew this little graph to try to guess what I thought the graph would look like. And over here, I've got the actual graph. And so you can see my graph is a little bit off. It went a lot further lower than I thought it would. You can see this scale x-axis. But still, importantly, the graph came in and bounced off -4. It came up a tiny bit and then through -2, then it came way down and then up through 5. So I kind of, although my graph was off a little bit, I should have tested a few points here to graph them. But you can see how my graph is pretty close to the actual graph that the computer gets. All right, so let's do the two of the hardest problems in this class. We're going to tackle them right now. We need to factor this right here. This is what we're going to factor, and that means finding all of the numbers that if you could plug them in, you would get 0. And that's going to be difficult to do because of this stinking 2 right here. So I've listed the steps, and I'm going to let you read them on your own time. I'm just going to show you how to do this. So first we need to list all of the possible factors. And all of the possible answers are this number divided by this number. So the factors of 2 are 1 and 2. And the factors of 12 are 1, 2, 3, 4, 6, and 12. So all of these numbers divided by these two numbers are our possible factors, our possible answers. So let's do it. So they're going to be positive or negative. By the way, it's positive or negative of all of these. So positive -1, positive -2, positive -3, positive -4, positive -6, positive -12. So those are all potential answers, and that's all of these divided by 1, okay? Now let's take all of these divided by 2. So first we have 1 divided by 2, which is a half. Now if I did 2 divided by 2, that would equal 1, and we've already got 1, so we can ignore that. 3 divided by 2, though, that one's not on our list. If I did 4 divided by 2, that would equal 2, which is already on my list. 6 divided by 2 is 3, which is on our list. And 12 divided by 2 is 6, which is on our list. So you don't need to put ones on your list that are redundant. So here is all of the possible candidates for being a factor. The next thing we're going to do is Descartes' rule of signs. So what that says is it gives us a map of what our answers are going to look like. So here's how you do it. We know we're going to get 3 answers because of the fundamental theorem of algebra. So an answer can either be positive, negative, or it could be complex, meaning it has an imaginary part. So here's how you tell how many it has. First, you count the number of sign changes. So there's a sign change, 1, but then we stayed negative, but then we changed signs. So we had 2 sign changes. So that means we're going to have potentially 2 positive answers. Now the next part's a little tricky. We plug in a negative for x. So we plug in a negative for x, and then we see what that would equal. So if I put a negative right here, that would be negative x to the 3, which would stay negative. If I put a negative here, that would become positive, and so it would stay negative because of that negative sign. If I put in a negative here, it would be negative and a negative, and so that would be a positive, and then we finish with a positive because there's no x's. So that's kind of weird. I plugged in a negative for x and saw what the final sign of each term would be. And so we see it's negative to negative, so no sign changes. Then we have 1 sign change, and then that's not a sign change. So that means that we are going to have 1 negative answer, okay? So because we have 3 total answers, one possible scenario is we're going to have 2 positive answers, 1 negative answer, and 0 positive. However, there's one other scenario. You can have an even number of complex answers. And so we could trade off those two positives for two complex answers. So our solution is going to be one of these two scenarios. And if this had been a 4, then you would count 4, 2, 0, and this would be 0, 2, 4. It's just two positives can trade with two complex answers. However, this one negative one is locked. That one's not going anywhere. Okay, so we know roughly what our answers are going to look like, and we have a bunch of potential candidate answers. So the next thing to do is to just, this is the boring part, you just plug in numbers and you try to find one that works. So I like to start by plugging in 1, so because it's the easiest. So let's plug in 1. 2 times 1 is 2. 2 minus, all of these are going to just be 1s. So it's going to be 2 minus 3 minus 23 plus 12. So 2 minus 3 minus 23 plus 12. Nope, that's not equal to 0. And so I know that positive 1 is not an answer. Let's try negative 1. If I plugged in negative 1 here, I'd get negative 2. This would stay negative, so it would be minus 3. This would become positive because it's a negative here, so that would be plus 23 plus 12. And we get a number that's not equal to 0, so 1 is completely out now. Darn it. So let's keep going. Let's try plugging in positive 2. 2 times 2 times 2 is 8, times 2 is 16. 2 times 2 is 4, times 3 is 12, so this is 16 minus 12. 2 times 23 is 46, so minus 46 plus 12. Dang it, 2 is not an answer. Sometimes these just take a while, so be patient. Negative 2, let's try that. Negative 2 times negative 2 times negative 2 is negative 8, times 2 would be negative 16. So negative 16. Negative 2 times negative 2 is 4. 4 times negative 3 is negative 12. So that would be negative 16 minus 12. Oops. Negative 16 minus 12. So negative 2 times negative 23 would be plus 46 plus 12. Dang it! I think we should get 30 with that, but either way, it's not equal to 0. So negative 2 is not an answer. That's okay. Just be patient. We'll get 1 eventually. How about 3? 3 times 3 times 3 is 27, times 2 is 54. 3 times 3 is 9, times 3 is 27, so minus 27. 3 times 23 is going to be 69, right? So minus 69 plus 12. Nope, 3 is not a solution. I'm feeling good about this next one, though. Let's try negative 3. Negative 3 times itself 3 times is negative 27, times 2 is negative 54. Negative 3 squared is positive 9, so that's going to be minus 27. Negative 3 times 23 is going to be 69, so that'll be plus 69. Plus 12. And look at that. Negative 3 is our savior in this problem. Negative 3 is a solution. So once we've gone through all of that pain, we've got a solution and we're going to be able to go from here. So I'm actually going to stop the video now because we found our first solution. And by the way, we didn't find any solution. We found a negative solution. So that means all the rest of these negatives are gone. They are not going to be an answer. Thanks to Descartes' rule of signs, we found our one and only negative solution. So that means only the other zeros possible are these numbers over here. So that's just wonderful. So now that we know that negative 3 is a solution, we're going to use synthetic division. And we'll start that in part 3. You saw how long that just took. And I've done this very many times. So just be patient. Finding your first root takes a while sometimes. Sometimes you get lucky and you find it right away. But sometimes it just takes a while to find your first root. But now that we found it, it's going to be all downhill from here. I will see you in part 3.